Welcome back to FreightWaves Live at Home. I'm JP Hampstead, Director of Passport Research, here with another Fireside Chat. And this time, Vijaysai Patnaik, Product Lead at Waymo Via, joins me. Vijaysai, thanks so much for being here.
Thanks for having me, JP. Really excited about this conversation.
Yeah, so you helped lead the self-driving car efforts at Waymo before going to the truck side. Can you tell me a little bit about your background and what you learned working on self-driving cars, and then what the new project is like?
Absolutely. So I started, as you pointed out, working on the passenger car side at Waymo, where we today have a live ride-sharing service with our fully self-driverless cars in Phoenix, Arizona. So I started by working on our perception systems, which is a part of the technology that takes all of the information from our sensors and helps our vehicles understand what's around them. And it was an amazing learning experience to take the technology and convert it into a product that today members of the public in Arizona, Phoenix, Arizona, use on an everyday basis. They give us feedback on it, and we iterate and continue to improve that product. While we were working on the passenger car side, I helped start the trucking efforts at Waymo because we saw a huge potential to make the trucking industry safer, stronger, and more efficient. And so we've been working on Class 8 trucks since about 2017, and I now spend all of my energy on trucking.
That's great. Now I can imagine that there are like so many different applications for self-driving technology in trucking, whether it's sort of the power units that just shift containers and trailers within a company's yard, whether it's drayage or something like that, local deliveries. What's kind of the range of applications that Waymo Via looked at, and where are you guys focusing on commercial vehicles first?
Yeah, so I'll start by giving a quick overview of Waymo itself and how we think about the technology, and then dive into your question about which areas we're focusing on first. So Waymo is a self-driving technology company based in Mountain View, California. Our focus is L4 self-driving technology, which means an empty car or an empty truck can move goods or people safely to where they need to go. And the way we think about it, we call this self-driving technology the Waymo driver. And the way we think about it is that the Waymo driver can have applications in a number of areas. So one of them is Waymo One, which we talked about briefly just now, which is our ride-sharing service for moving people. And Waymo Via is our service for moving goods, and that includes both trucking as well as local delivery. On the trucking side, our initial focus is on on-highway driving. So we're talking about routes where the majority of the miles are highway miles. Now, in order to take the goods to a depot, whether that's a LTL terminal or a warehouse or a distribution center, we will also be fully driverless on a limited amount of surface streets. However, the cases that you see of city driving, where there are trucks going to deliver goods to the neighborhood supermarket, those are more challenging cases for trucking that we'll tackle later. Now, as part of Waymo Via broadly, we do focus on that segment with our passenger cars, where I'll give you an example of a couple of partnerships that we have. One is with AutoNation, where car parts are delivered to various dealerships using our passenger cars. Another is a partnership we have with UPS, where packages are being delivered from their store to their hub. But on the trucking side, that kind of city driving for us will come later, and the first focus is on highway driving.
Got it. That makes sense. So, I think there are some pretty important differences between the way that passenger cars move, the kinds of environments they find themselves in, the way that those drivers behave compared to commercial vehicles. Can you talk about some of the most significant differences that your team has found in applying self-driving technology to passenger cars and commercial vehicles?
Yeah, so there are a few areas where trucks differ from cars. Some of which may be obvious to you and the audience. One is the domain itself. So trucks spend a lot more of their time on the freeways and highways, which are higher speed environments. They have a lot more mass. They're slower to accelerate and brake compared to passenger cars. They also have trailers which can move semi-independently of their own, so you have to take that into account in the vehicle dynamics. And the trailers can also be carrying a varying amount of load. So these are some of the big differences we see, and of course, maneuvering for trucks is different. So the way a truck will take a turn going over the yellow lines and over multiple lanes is quite different from how cars would navigate turns. So we take that into account in both our hardware as well as software development. To give you a couple of examples, when we think about where to place our sensors and how to place them, we take into account the fact that our trucks need to be able to see further on the freeways, that they have different blind spots than the cars. And so we want to place our sensors such that they can see all the way along the sides and in front of the truck clearly. When we do software development, we also take into account some of the different maneuvering I was talking about. We take into account how the vehicle dynamics and hence how we do the braking and acceleration needs to change to account for varying loads that the truck might be carrying. So the good thing for us is that we're able to leverage a lot of the self-driving technology and infrastructure that we built up over 11 years of the history of the company and adapt it to trucking rather than having to develop it from scratch. So the hardware that we use, it's the same custom built suite of sensors and computer that had been developed and refined over the years, just placed differently on the trucks. When we talk about the software, the core algorithms of how we perceive objects around the vehicle or how decisions about changing lanes or mergings are made, that remains the same. It has to be adapted to a different domain and to take into account the different size of the vehicle. Same goes for all of the infrastructure. For example, simulation, if we have the opportunity, I'll tell you more about it, but all of that simulation infrastructure, which is critical for development of this technology, is the same across cars and trucks. So we are really able to leverage a lot of the work done over the 11-year history of the company and benefit from the same advanced software, as well as the 20 million miles we've driven on public roads and 10 billion miles in simulation to accelerate the development of self-driving technology for trucking.
That makes a lot of sense. Vijaysai, you're product lead at Waymo Via, meaning that you spend a lot of time with customers trying to understand their problems and find solutions that Waymo can build that make sense for the customers and for Waymo. So a couple of questions here that are kind of related to that role. First, what do your customers want from a self-driving solution? And secondly, who are your customers? Where is the demand for self-driving technology coming from? Is it from shippers? Is it from trucking carriers? Is Waymo itself going to be a trucking carrier? Can you kind of help me think through whose problems you're trying to solve?
Yeah. So first, let me answer the question of who's seeing value in this and where is the demand coming from. So I think we see demand from different kinds of fleets. So whether it's a private fleet or whether it's a for-hire carrier, if you think about the value proposition of self-driving trucks to the industry around increased safety, mitigating the driver shortage issue, increasing efficiency, that value proposition appeals to all kinds of fleets. And so in our conversations with them, we've seen enthusiasm across the board. And our goal really is to make this technology widely available to fleets of all kinds. In terms of how we think about working with the various stakeholders, our approach really here is to partner and enable. So we are not a trucking company. We are not a trucking manufacturer. We're not trying to build trucks of our own. Our goal is partner and enable. So we want to work with OEMs, tier ones, fleets, maintenance partners, drivers in order to both develop this technology and bring it to market.
Okay, no, that's really helpful. Because with the Waymo for cars, you guys are actually offering a ride-sharing service, but Waymo Via, it's not offering trucking services for hire in the same way, right?
That's right. Today we own a fleet of trucks that we utilize for testing and for running pilots. But in the future, we hope to partner with the various stakeholders I mentioned.
Got it. Can you tell me a little bit about maybe what you've learned as you've worked on creating self-driving technology for trucks? And I'm most interested in, I guess, the unforeseen challenges or the surprises that you've encountered along that journey.
Yeah, and it's so first of all, I will say that it's been a positive surprise. When we started the project, one of our goals was to understand how well will this Waymo driver, the self-driving technology that was initially developed with passenger cars in mind, adapt and be able to transfer over to trucks. So we were very positively surprised by that. Within a very short amount of time since we started working on the project, we were able to have self-driving trucks safely testing in closed course environments and subsequently on public roads. Let me talk about a challenge that we faced that was unique to trucking. It's not today, you can't order a truck or easily build a truck that has all of the redundancies necessary for doing full self-driving. So this is L4 driving, where an empty truck should be able to transport goods in a safe and efficient manner. And let me touch on this concept of functional safety for a second to make that point. So functional safety is this concept that there shouldn't be any system failure anywhere in the system that would lead to any unsafe operation, meaning even if there is a system failure, the self-driving truck is able to either safely continue operating or come to a safe stop. And having that kind of functional safety requires redundancy in various parts of the system, whether that's braking, steering, power systems, the computer, sensors, so forth. And on the car side, we had developed multiple generations of passenger cars with that redundancy. And so those cars were capable of L4 fully self-driverless operations. On the truck side, we found that the industry is not there yet in terms of maturity on that front. So what we're doing to tackle that challenge is, fortunately for us, we have the experience of what it took to do this on the passenger car side, enable these cars to have all the right redundancy features. So we're taking the same learnings and methodical approach and working with OEM and Tier 1 partners to make sure that we can develop trucks that have the same capability.
Yeah, the redundancy issue, I think, is going to be really important, and it really, I think, involves a kind of a complex orchestration among so many different companies to make sure that the trucks are truly ready for self-driving technology. That's fascinating. Another question I have, and I think that probably are on a lot of people's minds, the more media they consume about self-driving technology, especially as it applies to trucks, is there are a lot of fears that maybe you would characterize as misconceptions about the disruptions caused to employment, for example, by the deployment of self-driving technology, maybe also just the way that trucking carriers operate, the way they differentiate themselves, and that sort of thing. Can you talk a little bit about the misconceptions that you've encountered as you've gone to pitch self-driving technology, and maybe kind of enlighten us as to how Waymo thinks about these issues?
Yeah, no, boy, there's quite a few we've encountered. So you touched on some of them. Let's start with two of the most common ones, maybe. So the first one is that self-driving trucks will become commonplace overnight or very, very quickly. So in reality, the rollout of this technology will be gradual and will phase in for different segments of the industry and in different geographies over time. So I just wanted to tackle that one up front and say that this change is not going to be a sudden change that will catch everyone by surprise. It's a gradual change that we will partner and enable the ecosystem to tackle well. The second one is around disruption, and you touched on this briefly. Going back to what I was mentioning, the idea here is not to somehow disrupt the existing ecosystem of OEMs, tier ones, drivers, maintenance partners, and the whole trucking industry. It's how can we partner with them, because at its core, Waymo is a technology company. Our focus is on building the Waymo driver, the self-driving technology that can enable safe and efficient movement of goods. And so we want to work with folks who are already best at what they do and bring this technology to market. So that's the second point, sort of misconception we often hear around disrupting the existing ecosystem. Maybe I'll touch on a couple more that also comes up in conversation. One is around this concept of teleoperations. So we often, when we show them videos or demos, people will ask, so is there a person sitting there who's remote controlling the vehicle or can take over control of the vehicle? And that concept of teleoperations is a misconception. So especially at Waymo, there is nobody sitting, in an office somewhere with a steering wheel and brake pedals who can take over control of the vehicle. The Waymo driver, the self-driving truck, is in control of the driving task at all times. Now, we do have what's called a fleet response team that can provide some information to the self-driving truck if it needs it, but by no means can they control the truck. So as an example, let's say the truck comes across a construction zone at night and it's the hard-to-read sign or the way that the lanes have been shifted over to create a new corridor of driving is a bit confusing. And those can be pretty hard for humans to tackle as well. So it can request a second pair of eyes and say, hey, I think this is the driving corridor. Can you confirm that's the case? And our fleet response team can look at the data, confirm it. The truck then makes a driving decision. It says, okay, I'm going to proceed. I'll lane change. I'm going to go at this speed, and this is how I'm going to navigate this construction zone. So that's kind of the third misconception around teleops. And maybe I'll touch on one more, which is around infrastructure. And this is a question that comes up, we see in some forums. Hey, so what infrastructure needs to be put in place for self-driving trucks to be a reality? Will there be AV-specific lanes? Will there be some V2V infrastructure? And the reality is, the way we're developing the technology, we're developing it to drive on roads as they are today. So it doesn't require any special infrastructure to become available. Now, any infrastructure that authorities put in place that improves the overall safety for just everyone, like if you're improving traffic flow or fixing potholes, will also help self-driving trucks, but that's not necessary for bringing this technology to market.
Thanks. No, that's really helpful. I love the stuff about the remote, driver or whatever, and the infrastructure. I think are really two important points of clarification that are really crucial. One of the things that I'm kind of obsessed with when I think about self-driving technology are the second-order effects, some of which may be unanticipated by people who talk about just how much money a trucking carrier could save if they didn't have to pay a driver. Things like how does the shape of a logistics network change when hours of service no longer exist, or what happens to trucking margins when it's robots competing against robots that can in capacity becomes almost endless. So my question to you is, what is the one big change in the future that you think could happen once self-driving trucks become ubiquitous?
So I think the biggest, I don't know if it's the biggest change, but one big change to think about is the impact on consumers. So individuals like you and me, how does our life change if this technology comes to market? If goods can move around in a more efficient manner, more safely, faster than before, then you can imagine the positive benefits that it brings to consumers in terms of both speed of delivery as well as the prices of goods. And this technology can really enable that because it can help reduce the fleet downtime as well as incidents on the roads. So that's kind of the impact on consumers, who many of whom don't even realize the crucial role trucking plays in their entire life, right? So anything we are eating, wearing, using has been on a truck at some point or the other. So if that whole industry becomes more efficient, consumers will see benefits. The other one you raised, talking about the business side and the trucking industry side, if the industry is free from constraints around hours of service or having to bring the truck back to a certain location, or having it to come back to its domicile, then we can imagine various ways in which the logistics networks of today might itself change. And this is currently speculation, and we'll see how this will evolve. But even in our conversations with fleets today, they remark about how, if these constraints go away, they might re-architect their network to make it easier and faster and more efficient to deliver goods. So I think on the trucking industry side, over the longer term, not immediately, we'll probably see some changes in supply chains.
Vijaysai, thank you so much for your time. It was a pleasure talking to you and learning about sort of where we are with self-driving technology for trucks. Thanks again.
It was a pleasure speaking to you. Thanks for your time.